Hi there. If you touch a piece of metal and a piece of wood, both at room temperature, have you ever noticed that the metal feels colder than the wood?
That's so strange, Aaron. Aren't they both at the same temperature?
Yes, Jesse. To understand this, we need to flesh out the difference between heat and temperature. When you touch the metal, the thermal energy transfers away from your body faster than it does when you're touching wood.
What is thermal energy anyway?
Good question. In Chapter 7 of Energizing Physics, students will explore all these questions, learning to picture vibrating molecules and calculating the transfer of energy, called heat, in all sorts of everyday situations.
And students will shake a plastic bottle full of sand over and over and explore how the joules of work they do result in the change in the sand's temperature.
Energy is energy, but thermal energy is another form that is all around us.
Students will explore how different materials heat up differently, how phase changes require energy, how different materials transmit heat at different rates, which is related to the insulation provided by your coffee mug or your house's walls.
At the end of the chapter, students will be challenged to apply computational physics to predict the final temperature of an ice-water mixture after a certain amount of time.
We think Chapter 7 is really hot, and the students think it's cool. Have fun.
Some big questions in Chapter 7 include: what is the difference between heat and temperature? Can we feel temperature? What happens when you add thermal energy to a substance? How can we conserve thermal energy? To understand the difference between heat and temperature, students will be confronted with situations where their sense of temperature is unreliable. This is because they are actually feeling heat, not temperature. Students will then investigate how the change in temperature is related to work, or some energy source. Students will use ice and wax to investigate thermal behavior during phase changes. Students connect thermal energy to kinetic theory of matter by considering models for each phase. Lastly, students connect all the concepts to insulation and how we conserve thermal energy. At the end of the chapter, students will bring everything together to predict the temperature of an ice-water mixture. Here's the outline of Chapter 7's lessons. We hope you and your students enjoy it.